the sun, the blazing sphere of fire that has watched over us for more than 4.5 billion years. Every morning, without fail, it rises in the sky, warming the earth, nourishing life, and giving energy to every living thing that has ever existed on this planet. Yet, as eternal as it feels, the sun too has a destiny, a fate written in the laws of physics. One day, far in the future, the sun will die. Welcome to Starsky Science, where we explore the great mysteries of the cosmos. If you're fascinated by space, stars, planets, and the ultimate fate of our universe, make sure to subscribe to this channel. That way, you'll never miss any of our documentaries. Today, we begin an extraordinary exploration, the story of how the sun, our life giver, will one day transform, fade, and finally perish. It may sound like the plot of a science fiction movie, but everything you are about to hear is based on real science, the work of astronomers, physicists, and missions led by NASA and other space agencies around the world. When we look up at the sun, we see brilliance, stability, and warmth, but deep inside its fiery core, forces beyond imagination are at work, forces that will one day seal its fate. To understand how the sun will die, we must first understand what it is today. The sun is a star, but unlike the billions of distant suns we see twinkling in the night sky, this one is close, so close that it dominates our sky and our lives. It is a colossal ball of hydrogen and helium gas, so massive that it accounts for 99.8% of the total mass of our entire solar system. Imagine this: everything, the planets, the moons, the asteroids, comets, even the Kuiper Belt beyond Neptune together, make up less than 0.2% of the solar system's mass. The sun holds everything together with its gravity. Without it, Earth and all the other planets would simply drift away into the cold darkness of space. But the sun is not just a gravitational anchor, it is also an engine of light and heat. At its core, nuclear fusion converts hydrogen into helium, releasing enormous amounts of energy. Every second, the sun fuses about 600 million tons of hydrogen into helium. To give you perspective, the amount of energy released every second is more than 1 trillion nuclear bombs exploding at once. And yet, this fury of energy is carefully balanced. The crushing weight of gravity tries to squeeze the sun into itself, while the energy from nuclear fusion pushes outward. These two forces, gravity pulling in, fusion pushing out, create a delicate balance called hydrostatic equilibrium. It is this balance that makes the sun stable. Every moment of life on Earth depends on the sun. Plants capture its light through photosynthesis, turning sunlight into food. Animals eat the plants, and predators eat the animals, creating the vast and complex web of life, all fueled by solar energy. Even fossil fuels like coal and oil are essentially stored sunlight from millions of years ago. But the sun is more than just a provider of energy, it is also a protector. Its magnetic field powers the solar wind, a constant stream of charged particles that flows outward across the solar system. This solar wind shapes the heliosphere, a giant bubble around our solar system that shields us from cosmic rays, high-energy particles, from distant galaxies that could be harmful to life. NASA's Parker Solar Probe, launched in 2018, is the closest human-made object to ever touch the sun. Its mission is to study the solar wind, the corona, and the mysterious processes that heat the outer atmosphere of the sun to temperatures far hotter than the surface. The data collected by Parker is helping scientists understand the behavior of our star in ways never possible before. Think about it. The sun is not just a burning ball of fire, it is a complex, dynamic system. It has sunspots, solar flares, and coronal mass ejections, massive bursts of plasma that can hurl billions of tons of material into space at speeds of millions of kilometers per hour. These events can sometimes impact Earth, disrupting satellites, power grids, and communication systems. Yet, they are also signs of the incredible energy within our star. Astronomers classify the sun as a G-type main sequence star, often simply called a yellow dwarf. It is in the middle of its life, stable, and not too big or too small. Stars much larger than the sun burn brighter but live shorter lives, often ending as supernovae. Smaller stars, like red dwarfs, burn more slowly, and can live for trillions of years. Our sun is somewhere in between. It is about 4.6 billion years old, and scientists estimate it has roughly 5 billion more years before it begins to change dramatically. That may sound like an unimaginably long time, but in cosmic terms, it is just the blink of an eye. The clock is ticking. The sun is slowly changing. Every 100 million years, it gets a little brighter, about 10% more luminous, every billion years. That means that in the future, Earth will receive more solar energy than it does today, enough to eventually boil away the oceans and make life as we know it impossible. So, what happens when the sun begins to die? What will it mean for Earth, for the other planets, and for humanity itself? These are not just abstract questions. They shape our search for knowledge, for exoplanets around other stars, and for the possibility of moving beyond our solar system one day. This is why scientists at NASA, the European Space Agency, and observatories around the world study the life cycles of stars. By understanding how stars live and die, we also understand the future of our own home. By the way, if you're enjoying this exploration, don't forget to subscribe to Starsky Science. We bring you deep, fact-based documentaries about the universe, and your support helps us continue sharing these cosmic stories. To truly understand its future, let's peel back the layers of the sun. Core, the powerhouse, where temperatures reach 15 million degrees Celsius. Here, hydrogen atoms fuse into helium, releasing energy through the process of nuclear fusion. Radiative zone, above the core, energy slowly moves outward, but it takes time. In fact, a single photon of light produced in the core can take tens of thousands to millions of years to escape through this dense region. Convective zone, in this layer, energy moves faster, carried by giant currents of plasma that bubble and churn like boiling water. Photosphere, this is the visible surface of the sun, glowing at about 500 degrees Celsius. Chromosphere and corona, the outer atmosphere, hotter than the surface, where solar flares erupt and the solar wind begins. The fact that the sun's corona is hotter than its surface is one of the great mysteries of solar physics. Imagine standing near a fire. The closer you are, the hotter it gets. But the sun doesn't behave that way. Its outer atmosphere, the corona, can reach temperatures of millions of degrees, far hotter than the photosphere below. Scientists still don't fully understand why, though magnetic fields and plasma interactions seem to play a role. The sun's story is one of balance. But no balance lasts forever. Deep inside the core, hydrogen fuel is slowly running out. For billions of years, fusion has converted hydrogen into helium. Over time, the helium accumulates in the core, making it denser. As the sun ages, it will struggle to maintain equilibrium. Gravity will squeeze harder, the core will heat up, and eventually, new reactions will begin. This slow change is the beginning of the end, the silent countdown to the sun's death. Even though the sun still has billions of years left, its future is written. Stars like the sun do not live forever. They are born, they shine, they evolve, and eventually, they fade. And when our sun dies, it will not go quietly. We've explored the sun as it is today, the life giver, the stable star, the center of our world. But now we must look ahead. What happens when the fuel runs low? What transformations await? And how will Earth and humanity survive the changes to come? Stay with us, because the story of the sun's future is as dramatic as any tale in the universe. The sun feels eternal. Day after day, it shines unchanged in our skies. But science tells a different story. Even now, as we live our daily lives on Earth, the sun is changing. Its brightness is slowly increasing. Its fuel is slowly depleting. The seeds of its eventual death have already been planted. Let's step into the timeline of the sun's future. Not tomorrow, not next year, but billions of years from now. What will happen when our life-giving star begins to unravel? Right now, the sun is in the stable phase of its life. Astronomers call this the main sequence. It's the period where a star burns hydrogen in its core, keeping a perfect balance between gravity pulling inward and the outward push of energy from fusion. But this phase doesn't last forever. With every billion years that pass, the sun becomes about 10% brighter. That might sound like a small change, but over long timescales, it transforms Earth in ways we can hardly imagine. Fast forward about 1 billion years from now, Earth's surface will begin to heat up. Temperatures will rise to levels where the oceans start to evaporate. Water vapor, a greenhouse gas, will trap even more heat. The cycle will accelerate, turning our once blue planet into something resembling Venus, dry, scorched, and hostile to life. By 2 billion years in the future, Earth's oceans will be completely gone. The continents will bake under a relentless sun, and life as we know it will vanish. Microbial life may linger for some time, in protected pockets, deep underground, or in high-altitude clouds, but eventually, even that will fade. It's a chilling thought. The very star that gave us life will one day take it away. Dr. Jill Tarter, an astronomer who has spent her career studying stars and the possibility of life beyond Earth, once said, "Stars don't live forever. We have to face the reality that the clock is ticking, even for our sun. But the awareness of that fact is also what drives us to search the cosmos for other worlds, for other suns." NASA scientists studying the sun's evolution emphasize the same point. According to models of stellar physics, the sun's main sequence will last around 10 billion years in total. We are already halfway through that lifespan. That means the sun is middle-aged stable. Yes, but past its youth. The earliest signs of the sun's decline won't be a sudden explosion or dramatic collapse. Instead, it will be subtle. Earth's climate will gradually shift. Carbon dioxide will be pulled from the atmosphere faster due to higher temperatures and rock weathering. This will make it harder for plants to survive, reducing oxygen for animals. Eventually, even before the oceans fully evaporate, complex life will vanish. The Earth will return to being a barren world. Imagine that scene. No forests, no rivers, no animals roaming the land. Only dry, cracked deserts stretching across continents, under a sun that shines brighter than it does today. And yet, even in that bleak image, there's something profound. Humanity, if still around by then, will have long since left. Our fate will not be tied to Earth's decline. We will either move outward to the stars or vanish into history. Now, leap forward 5 billion years. This is when the real transformation begins. At this stage, the sun will have consumed nearly all the hydrogen in its core. Without fresh fuel to fuse, the delicate balance between gravity and pressure will break. The core will contract under its own weight, heating up to even higher temperatures. Meanwhile, the outer layers of the sun will swell outward. The sun will expand into a red giant. This is not a small change. The sun's diameter could grow to more than 100 times its current size. Mercury will be swallowed. Venus will almost certainly be engulfed. And Earth? That is one of the greatest questions of solar physics. Some models suggest Earth will also be consumed, pulled into the sun's outer atmosphere. Others suggest it may barely survive, but scorched, its surface melted and barren, orbiting on the edge of a dying star. Either way, the Earth we know, the home of humanity, will be gone. The sun as a red giant will be a spectacular sight, at least from a safe distance. Its outer layers will glow with a deep red hue. Solar winds will become fierce, blasting material into space at speeds that reshape the entire solar system. Astronomers studying other stars can see previews of this future. Stars like Aldebaran in Taurus or Betelgeuse in Orion are already in their red giant stages. By looking at them, scientists are essentially looking into the future of our own sun. NASA's Hubble Space Telescope has even captured images of stars in this stage, shedding their outer layers, creating massive clouds of gas that will one day form new stars and planets. Our sun, too, will contribute to this cycle, its death, paving the way for new cosmic beginnings. Think of the irony. The sun, which has been constant for all of human history, will one day become a bloated, unstable giant. The skies of the future, if anyone could see them, would be dominated not by the gentle sun we know, but by a vast, red, glowing giant filling the horizon. But remember, this is not tomorrow. This is billions of years away. Our story here is not about fear, it is about understanding. Understanding the life cycle of stars, and by extension, understanding our place in the universe. By the time Earth begins to heat beyond habitability, humanity, or whatever descendants of humanity exist, will have choices. If technology advances as many believe it will, colonizing other planets or moons could become possible. Mars, icy moons like Europa or Titan, or even artificial space habitats could serve as refuges. But ultimately, even those worlds lie within the sun's grasp. As it expands into a red giant, the habitable zone, the region where liquid water can exist, will shift outward, perhaps reaching as far as Jupiter or Saturn. Worlds that are frozen today, like Europa, could briefly thaw, their icy shells melting into oceans under the red glow of the sun. Life could briefly bloom again in these outer regions, but it would be temporary. The sun's instability means nothing will last forever. That's why astronomers and futurists believe that, in the very long term, the only real solution for survival is moving to other stars. Our sun will not last forever, but the universe is filled with billions of stars, many younger and more stable than ours. If you're fascinated by these cosmic truths, take a moment to subscribe to Starsky Science. It helps us share these stories of the universe with more curious minds around the world. As the sun sheds its outer layers, it will lose a significant amount of its mass. This change in mass will weaken its gravitational pull. Planets farther out, like Saturn, Uranus, and Neptune, will drift into wider orbits. Some may even be ejected from the solar system altogether, wandering through space as rogue planets. The inner solar system will be a place of chaos. Moons will be stripped from their planets. Asteroids will be hurled into new paths. The once stable clockwork of planetary motion will be disrupted. This will be the true death throes of the sun, a time when the solar system we know is unmade, piece by piece. In the end, the sun's death is not just about astronomy. It is about perspective. It reminds us that even the mightiest forces we know are temporary. Stars are born, they shine, and they die. The universe itself is a constant cycle of creation and destruction. And yet, within that cycle, there is beauty. The atoms in our bodies were forged in the hearts of ancient stars that died long before our sun was born. When the sun dies, its material will spread into space, perhaps one day forming new worlds, new suns, and maybe even new life. We've now seen how the sun's steady light will turn into a searing blaze, boiling oceans and scorching earth. We've glimpsed the vision of a swollen red giant swallowing worlds. But this is not the end of the sun's story. After its red giant phase, something even more remarkable happens. The sun shrinks, transforms, and leaves behind a remnant unlike anything we've yet imagined. Imagine standing on the last days of Earth. The sky is no longer blue, but red, dominated by a swollen sun that stretches across the heavens. Mountains glow under its light. The air is thin and burning. Oceans are gone, forests erased, and the surface of the planet is nothing but lifeless rock. This is no science fiction. This is the destiny written in the physics of our star. The sun, once gentle and stable, will transform into a red giant of unimaginable scale. And when it does, the solar system will never be the same. The death of a star like the sun begins deep inside. As hydrogen in the core runs out, fusion slows. Gravity, relentless and patient, squeezes the core tighter and tighter. The temperature rises to more than 100 million degrees Celsius. At this point, something extraordinary happens. Helium atoms, once too resistant to fuse, now collide and merge. The sun begins burning helium into carbon and oxygen. But this ignition is not gradual. It is violent. Astronomers call it the helium flash. In just a few minutes, the core releases an amount of energy equal to what our sun produces in millions of years. Yet, because the sun is so massive, this explosion is buried deep inside, invisible from the outside. Still, the effects are enormous. The sun stabilizes for a time, glowing even larger and brighter. For roughly 100 million years, a blink in cosmic time, the sun will fuse helium steadily, shining as a true red giant. As a red giant, the sun's radius could extend beyond Earth's orbit. Earth may be swallowed whole. If it survives, it will be a scorched ember, orbiting inside the sun's outer atmosphere. From a distance, say, the icy moons of Jupiter, the view would be spectacular. The sun would appear not as the small disk we see today, but as a gigantic blood-red sphere dominating the sky. Its fiery surface would ripple with convection cells the size of continents. Solar winds would tear through the system, creating storms of radiation and plasma. Astronomers often compare this phase to a star entering its grand finale. For billions of years, the sun has been calm, predictable, but as a red giant, it becomes chaotic, unstable, and violent. What would happen to the rest of the solar system under this new red star? Mars might become briefly habitable. Its frozen ice could melt, releasing water. For a short window of time, Mars could see rivers and lakes again, though under a sky of fire. Jupiter's moons, like Europa and Ganymede, might thaw. Their icy shells could crack open into vast oceans, heated not by geothermal vents, but by the glare of the sun itself. Imagine seas shimmering under a red giant sky. Saturn's Titan, with its methane lakes, could warm, changing its chemical balance, and perhaps creating conditions for new, exotic forms of life. But these worlds would not remain safe for long. The sun's instability means these habitable windows would be temporary. As the red giant phase continues, the sun will grow unstable. Its outer layers, no longer tightly bound by gravity, will begin to drift into space. Powerful solar winds will carry away billions of tons of gas every second. Slowly, the sun will shed its skin. This gas, glowing under the ultraviolet light of the hot core, will form magnificent shapes in space. Rings, shells, and clouds of color will spread outward. To a distant observer, the sun will look like a cosmic flower blooming in its last moments. Astronomers call these creations planetary nebulae. Despite the name, they have nothing to do with planets. They are the last breath of dying stars, like the sun. One day, billions of years from now, another civilization, perhaps alien astronomers far across the galaxy, might look through their telescopes and see a glowing nebula where our sun once shined. They would not know the story of Earth, of humanity, of the lives that once danced under that star. To them, it would be just another nebula, one of millions across the Milky Way. And yet, to us, it will be the ultimate reminder: even stars must die. Astronomers do not need to wait billions of years to study this process. Across the galaxy, we see stars just like the sun in their dying phases. The Ring Nebula in Lyra is the remains of a star almost identical to the sun, now shining as a glowing ring of gas. The Helix Nebula, sometimes called the Eye of God, is another star's last breath, its outer layers cast into space, leaving a faint white core. The Eskimo Nebula and the Butterfly Nebula show the astonishing diversity of shapes that dying stars can create. By studying these remnants, NASA scientists gain a window into the sun's fate. As Dr. Mario Livio, an astrophysicist, once put it, when we look at planetary nebulae, we are looking into a mirror of the sun's future. This is what awaits our star. But what about the sun's heart? As the outer layers drift into space, the core remains behind. This core, no longer burning hydrogen or helium, shrinks under gravity's grip. But before it can collapse completely, quantum physics steps in. The pressure of electrons, a strange effect of quantum mechanics, holds it up. The result is a white dwarf, a star's skeleton. The sun, once a blazing giant, will become a tiny ember, no larger than Earth itself. Yet it will still be unimaginably dense. A teaspoon of white dwarf material would weigh tons. At first, the white dwarf will shine brilliantly, glowing with the leftover heat of its collapse. Over billions of years, it will slowly cool, fading into darkness. Eventually, it will become a black dwarf, a cold, dark remnant, invisible in the night sky. This is the true death of the sun. So much drama, so much violence just to reach silence. From the red giant's chaos to the quiet ember of a white dwarf, the sun's story is one of transformation. And in that transformation, we see the cycle of the cosmos. For the material shed by the sun, its gases, its atoms will not be wasted. They will drift through the galaxy, mixing with clouds of hydrogen, forming new stars, new planets, and perhaps new life. The death of the sun will not just be an ending, it will be a beginning. By the way, if you're finding this vision of our sun's fate fascinating, take a moment to subscribe to Starsky Science. It's the simplest way to join our journey through the cosmos and support the work that brings these stories to life. It's difficult for us to imagine timescales of billions of years. Human history is a mere flicker compared to the life of the sun. The pyramids of Egypt were built only 50 years ago, an instant compared to the sun's 4.6 billion years of age. When we think about the sun's death, it's easy to feel small, even insignificant. But there's another way to see it. We are alive at the perfect moment. The sun is stable, Earth is habitable, and we have the chance to understand it all. This perspective is what drives science. The knowledge that nothing lasts forever, and that by studying the cosmos, we can glimpse both the past and the future of existence itself. So now we know the sun will swell into a giant, burn helium in a final blaze, shed its outer layers in a cosmic display, and leave behind a glowing white dwarf. But there's still more to explore. What will happen to the planets that survive? How will the solar system look after the sun is gone? And what lessons does this fate hold for humanity today? Stay with us as we continue deeper into the greatest story ever written, the story of our star. The sun, our great giver of life, is not eternal. For billions of years, it has been stable, calm, almost gentle, burning in harmony, as if nothing could disturb its timeless rhythm. But deep inside its heart, a slow and irreversible clock is ticking. Each second, millions of tons of hydrogen are consumed, transformed into helium. And while it feels endless to us, this process is gradually steering the sun toward its most dramatic and violent future. Scientists often say that stars live and die like living beings. They are born, they grow, they change, and ultimately, they fade. And for our sun, the future holds one of the most terrifying spectacles nature can offer, a fiery expansion so vast, so powerful, that it will shake the very architecture of the solar system. This stage is known as the red giant phase. And when it begins, Earth will face a cosmic trial unlike any other. The sun's brightness has been steadily increasing since its birth 4.6 billion years ago. This rise is so slow that life on Earth has had time to adapt. But in the far future, roughly 1 to 2 billion years from now, this gradual increase will begin to push our world into dangerous territory. Earth's oceans will start to boil away under the relentless heat. Water vapor, once our planet's protective friend, will become a greenhouse gas, trapping even more heat. The atmosphere will turn into a suffocating blanket of steam and carbon dioxide. Plants will die first, unable to survive the soaring temperatures. Then animals. And finally, even the most resilient microorganisms will find survival impossible. NASA's simulations suggest that Earth will resemble Venus, a scorched, uninhabitable wasteland, a silent, empty planet under a brutal sun. But this is only the beginning. As hydrogen runs out in the sun's core, nuclear fusion can no longer maintain balance. Gravity begins to win, pulling the sun's center inward. The core heats up not just a little, but unimaginably so, reaching over 100 million degrees Celsius. This extreme heat forces the outer layers of the sun to expand. Slowly at first, then faster, the sun balloons outward, swelling to sizes that defy comprehension. From our current perspective, the sun spans about 1.4 million kilometers in diameter. But as a red giant, it will grow over 100 times its current size. To put that in perspective, the sun's surface could extend far beyond Earth's orbit. Mercury, the smallest planet, will be swallowed whole, completely incinerated. Venus will meet the same fate. And Earth? Its destiny is more uncertain. Some scientists believe Earth too will be engulfed in the sun's blazing outer atmosphere. Others suggest that the sun may shed mass as it expands, causing Earth's orbit to drift outward just enough to avoid being completely consumed. But even if Earth survives, it won't be spared. The surface will be roasted, stripped of its atmosphere, and bathed in radiation. Our planet will no longer resemble the lush blue world we know. It will be a dry, lifeless rock. Here, the story becomes more than astronomy. It becomes a question of survival. By this time, if humanity or its descendants still exist, our species will face its greatest test: to leave Earth behind. Science fiction often imagines great fleets of starships carrying humans to other stars. But scientists at NASA and beyond consider something else. Could we find another planet within our galaxy, orbiting a stable star, to call home? Could we terraform Mars or build artificial habitats orbiting far from the dying sun? Dr. Michio Kaku, a theoretical physicist, once said, "Our destiny is to become a multi-planet species, because the Earth will not last forever. The sun's death is the most undeniable proof of this truth. If we succeed, future civilizations may look back at Earth as the cradle of humanity, a birthplace long abandoned but forever cherished. If we fail, Earth's story and ours may end under the crushing light of a dying star." As the sun becomes unstable, it will not only expand, but also pulse. These violent pulsations will cause it to lose enormous amounts of mass. The solar wind, a stream of charged particles, will grow to unimaginable strength, blowing entire outer layers of the sun into space. Jupiter and Saturn, the gas giants, may survive the sun's fury, but they too will face changes. With the sun losing mass, its gravitational grip weakens, and the orbits of the planets shift. Moons may break free. Some planets might even be ejected into the darkness of interstellar space. Imagine entire worlds drifting away into eternal night, carrying with them the frozen scars of the sun that once held them. Astronomers believe that in this chaotic time, the solar system will become unstable. Asteroids, comets, and even planets could collide, reshaping the system in catastrophic ways. The stable, orderly orbits we see today will dissolve into cosmic chaos. When the sun's core compresses enough, something extraordinary will happen. The helium that built up over billions of years will finally ignite in a process called the helium flash. For a brief moment, the sun will unleash a colossal burst of energy, a release so violent it defies comparison. This marks the beginning of helium fusion, where helium atoms fuse into carbon and oxygen. During this stage, the sun will burn brighter and hotter than ever. But this phase won't last long. While hydrogen fusion sustained the sun for billions of years, helium fusion will last only a fraction of that time, perhaps just a few 100 million years. In cosmic terms, that's a heartbeat. After the helium fuel is spent, the sun has nothing left to give. It can no longer support itself against gravity. But unlike larger stars, which explode in supernovae, our sun is too small to go out with such violent glory. Instead, it will shed its outer layers into space, creating a breathtaking planetary nebula, a glowing shell of gas that shines like a cosmic lantern. At its center, what remains of the sun will shrink down into a tiny, incredibly dense core, a white dwarf. This star remnant, no larger than Earth, will still be unimaginably hot, glowing with leftover heat. Over billions of years, it will slowly cool, fading into darkness. A black dwarf, a dead star. The sun's reign will be over. Picture it, the solar system in the far, far future. The planets, if they survive, will orbit a faint white dwarf instead of a blazing star. No warmth, no light, just cold, eternal night. The sun, once the giver of life, once the heart of Earth's beauty, will be nothing more than a cosmic tombstone, a silent reminder of the life it once nurtured. But life, as fragile and stubborn as it is, may find a way. Perhaps by then, humanity will have spread across the galaxy, carrying with it the story of the sun that made everything possible. And if alien civilizations ever discover the remains of our solar system, they may look upon the dead sun and wonder what stories, what beings once lived here. This is why we study the stars, not just to understand them, but to understand ourselves, our place, and our future. The sun's death is certain, but it is also a warning and a challenge. And here on Starsky Science, we continue to ask, will we be ready for the day the sun will die? The sun, the golden heart of our solar system, has burned steadily for billions of years. But its destiny is not to shine forever. One day, it will change. It will grow, transform, and finally fade into something very different. Scientists studying stellar evolution believe they already know, with remarkable precision, how our star's final act will unfold. And the truth is breathtaking and terrifying. You're watching Starsky Science, and if you haven't yet, don't forget to subscribe to our channel. Your support helps us keep bringing you incredible stories of the cosmos. Imagine looking up at the sky, perhaps a billion years from now. The sun no longer appears as the small, bright disk we know today. Instead, it has grown. It dominates the sky, swelling to hundreds of times its current size. Its color shifts from golden yellow to a deep, burning red. The sun has entered its red giant phase. Astrophysicists from NASA and ESA describe this stage as both inevitable and catastrophic. When hydrogen, the fuel that has powered the sun's nuclear fusion, finally runs low in the core, gravity and energy fall out of balance. The sun's core contracts under immense pressure, while its outer layers expand outward. The result is a swollen, red, dying star that stretches far beyond the orbit it once occupied. For planets like Mercury and Venus, this expansion is fatal. They will be engulfed by the bloated sun, swallowed whole. Earth stands on the razor's edge. Some models suggest it too will be consumed, while others argue it may just barely survive, scorched but intact. Either way, life as we know it cannot endure this transformation. From Earth's perspective, the changes are devastating long before the sun reaches its maximum size. Even as the sun begins to expand, it grows brighter up to thousands of times its current luminosity. Imagine deserts spreading across continents, oceans boiling into thick clouds of steam, and the atmosphere becoming suffused with greenhouse gases. Dr. Jill Tarter, a well-known astrophysicist, once described it as a slow-motion apocalypse. Earth does not explode, nor is it instantly destroyed. Instead, the planet is gradually sterilized, baked from above until not a drop of liquid water remains. For any life still clinging on in underground refuges or distant frozen regions, this marks the end. Earth becomes a dry husk, a world stripped of seas, atmosphere, and habitability. But here lies the fascinating question: where will humanity be? If our species survives for billions of years, a possibility some scientists entertain, given technological advancement, we will face the challenge of escaping the sun's deadly expansion. Some scientists argue we could migrate outward, colonizing Mars or even the icy moons of Jupiter and Saturn. As the sun swells, these once frozen worlds will briefly find themselves bathed in warmth. Europa, Ganymede, Titan, they may thaw, their surfaces turning into oceans, their skies illuminated by a red sun. For a fleeting period in cosmic time, these moons could become havens for life. Humanity, or whatever intelligent descendants follow, might carve out a new existence here, thriving under the glow of a dying star. Yet this solution is temporary. The red giant sun is unstable, and its expansion will eventually strip these worlds of their newfound habitability. As the sun swells, it loses mass. Gigantic solar winds, streams of charged particles blow across the solar system, weakening the sun's gravitational grip. Planets once locked in tight orbits drift outward, like dancers spinning away from a slowing partner. Astronomers using advanced simulations at NASA's Goddard Space Flight Center have modeled this process. They found that outer planets like Jupiter and Saturn will migrate farther from the sun. Asteroid belts may scatter. Moons could be set adrift. The solar system itself may destabilize, slowly unraveling over time. It's a reminder that stars are not just sources of light, they are anchors, holding entire systems together. And when the anchor weakens, the cosmic dance falls apart. After millions of years of instability, the red giant sun will shed its outer layers into space, creating one of the most beautiful sights in astronomy, a planetary nebula. Despite the name, this is not a planet at all, but a vast shell of glowing gas, illuminated by the dying star at its center. Through telescopes, planetary nebulae appear as colorful clouds, shimmering in blues, reds, and greens. Someday, the sun will produce such a spectacle, its final gift to the galaxy. At its center will remain a white dwarf, the core of the sun, compressed into an object no larger than Earth but with half the sun's mass. White dwarfs are astonishing. They are so dense that a teaspoon of their matter would weigh tons on Earth. And though they no longer fuse hydrogen, they glow with residual heat, slowly cooling over billions of years. Our sun's white dwarf phase will last longer than all of human history, many times over. In time, it too will fade, becoming a cold, dark remnant, a black dwarf. You might ask, how can we be so confident about the sun's future? The answer lies in the stars. Across the galaxy, astronomers observe countless stars at different stages of their lives. Some are young and hot. Some are middle-aged, like our sun. Others are red giants, or white dwarfs, already living out the fate we predict for our star. By studying these stars, scientists essentially see snapshots of the sun's future. Telescopes like Hubble and the James Webb Space Telescope provide breathtaking views of planetary nebulae and stellar remnants, confirming the theories of stellar evolution. Dr. Mario Livio, an astrophysicist, once explained it beautifully. When we look at dying stars, we are looking into our own future. The sun is not unique. It is part of a cycle written in the fabric of the cosmos. Here's a thought that blends science with philosophy. Even as the sun dies, what if humanity's legacy survives? Perhaps by then, humans will have ventured beyond the solar system. Colonies might exist around other stars, carried there by interstellar ships or robotic descendants. The death of the sun would then become not the end of humanity, but a footnote in our story, a reminder that while stars die, intelligent life may find ways to endure, carrying knowledge and memory into new regions of the galaxy. Carl Sagan often emphasized this point. The stars are not just destinations. They are lifeboats. The future of life depends on learning to navigate among them. As we reflect on the sun's fate, it forces us to confront a profound truth. Our lives, our civilizations, even our entire planet, exist within a temporary window of time. The sun provides warmth and energy, but only for a finite span. This doesn't mean despair, it means urgency. Studying the sun teaches us not only about the far future, but about the present. It reminds us how fragile Earth's balance is, how dependent we are on a star that seems eternal but is not. And as scientists explore ways to understand and even one day survive the sun's death, they push the boundaries of human imagination. This is Starsky Science, and if you haven't already, now is the perfect moment to subscribe to our channel. By doing so, you'll never miss the stories that connect our tiny world to the vast universe beyond. Stay with us, because the story of the sun's death is not just about destruction, it's about transformation, survival, and the eternal cycles of the cosmos. The sun? It has been our companion for nearly 5 billion years. Every morning, without fail, it rises and fills our skies with light, warmth, and energy. It's easy to believe that this eternal flame will burn forever. But science reveals a far more fragile truth. Our star, like all others, is mortal. And even though its death lies billions of years ahead, its fate is already sealed in the laws of physics that govern the cosmos. In this part of our documentary, we dive deeper into the most dramatic phase of the sun's future, the terrifying and awe-inspiring red giant stage. What will it look like? How will it feel here on Earth as our sun begins to expand into a swollen, glowing giant? And what do astronomers predict will happen to our solar system as the sun transforms into something unrecognizable? Scientists estimate that in about 5 billion years, the sun will exhaust the supply of hydrogen in its core. This simple element, the fuel of stars, has been sustaining nuclear fusion since the very birth of our star. But all fuel sources, no matter how abundant, eventually run dry. When that day comes, the delicate balance between gravity pulling inward and fusion pushing outward will collapse. Gravity will begin winning. The sun's core will contract, shrinking under its own enormous weight. Temperatures inside will rise to unimaginable levels over 100 million degrees Celsius. At this critical moment, hydrogen fusion will continue, but not in the core itself. Instead, it will take place in a thin shell surrounding the core, while the core compresses further, preparing to ignite helium. This unstable balance will trigger the sun's outer layers to expand outward, ballooning to a size so vast it will shock even the most prepared imagination. Our bright yellow sun will transform into a bloated red giant, swelling hundreds of times larger than its current size. Astronomers predict its radius could extend beyond Earth's current orbit. But what does that mean for us? Imagine Earth billions of years from now. Long before the sun becomes a true red giant, its increasing luminosity will have already made our planet unrecognizable. Oceans will evaporate. Atmospheres will boil away. The delicate ecosystems that sustain life will collapse. By the time the sun begins its red giant phase, Earth will be a scorched wasteland, a rocky, barren world resembling Mercury or Venus today. The surface will be molten in places, and the skies will shimmer with blazing radiation. And then comes the final question. Will the Earth be swallowed by the expanding sun? Astronomers debate this passionately. Some simulations suggest the sun's outer atmosphere will indeed engulf Earth, vaporizing our planet into nothingness. Other models suggest that as the sun loses mass through powerful solar winds, Earth's orbit might drift outward, narrowly escaping destruction. But even if Earth survives physically, it will be a shadow of its former self, an uninhabitable husk drifting around a dying star. Interestingly, as the sun becomes a red giant, Mars may briefly enter a habitable zone. Its frozen waters might melt. Temperatures could rise just enough to create a short-lived oasis. For a cosmic moment, Mars may be warm and blue, but this paradise will be fleeting. The sun's expansion will continue, and Mars too will eventually be scorched. Further out, the icy moons of Jupiter and Saturn, Europa, Ganymede, Enceladus, Titan may thaw. These frozen worlds, rich with water ice, could briefly become oceanic planets. Imagine Titan, with its methane seas, suddenly filled with liquid water and warmed by a distant red sun. Yet even these distant worlds will not remain safe for long. As the sun's evolution continues, the habitable zone will drift outward, eventually leaving the solar system's giants behind. From space, the sun as a red giant will be a sight beyond comprehension. Its glowing red-orange disk will dominate the sky, so large it will appear to fill half the heavens from the perspective of Mercury's lost orbit. For any civilization advanced enough to observe from a safe distance, the sun's transformation will be both terrifying and majestic. It will shine with a red glow, brighter than ever before. Solar winds will howl across space, stripping away atmospheres and scattering material throughout the solar system. And within this chaos, a new kind of fusion will begin. As the core shrinks and heats, helium fusion will ignite suddenly in what astronomers call the helium flash. In just seconds, the core will release more energy than the sun produces in millions of years. This explosive ignition will stabilize the star for a time. The sun will shrink slightly from its bloated red giant form, burning helium into carbon and oxygen at its core. This phase will last for perhaps 100 million years, a brief reprieve in the sun's turbulent old age. But nothing can stop the inevitable. Once helium is gone, the sun's endgame truly begins. The most haunting question is not just how the sun will die, but where humanity will be when it happens. If our species survives for billions of years, an extraordinary achievement in itself, we will not be on Earth to witness its fiery destruction. Long before the oceans boil, we will be forced to migrate. Perhaps we will colonize Mars, building underground cities protected from radiation. Or perhaps we will leap further, to the outer moons, turning Europa's oceans into vast human habitats. And perhaps, as many scientists and visionaries predict, we will not remain bound to the solar system at all. Humanity may scatter across the stars, settling near younger suns with longer lifespans. For us, the sun's death may serve as a cosmic warning, a reminder that even stars die, and survival means learning to adapt, to move, and to grow beyond our home. Astrophysicists at NASA, ESA, and observatories around the globe have been modeling this future for decades. Not because the sun's death is imminent, but because understanding stellar life cycles helps us understand the entire universe. Every star we see in the night sky is on a timeline, just like our sun. Some are newborns, others are nearing their ends. Studying them is like glimpsing our own destiny, written across the galaxy. And for humanity, it is humbling. Our lives are brief, yet we exist in the middle chapters of a cosmic story billions of years long. The sun will not burn forever. Its light, which has given life to Earth for billions of years, will someday fade. But in its fading, it tells us a deeper truth. Nothing in the universe is permanent. Stars die. Worlds change. And civilizations must learn to adapt or vanish. This is not the end of the story. It is the beginning of the most profound questions humanity will ever face. The sun, the very heart of our solar system, has always been our life giver. Every sunrise reminds us of its warmth, its light, and its unbroken rhythm. But one truth lies hidden within its glowing face. The sun, like every star, has a limited lifetime, and as it nears its end, it will not quietly fade into the night sky. Instead, it will undergo a series of violent, dramatic, and breathtaking transformations that will reshape the entire solar system. Here on Starsky Science, we explore these cosmic truths with detail and authenticity, bringing together the voices of scientists, researchers, and NASA's own observations. If you haven't subscribed yet, I invite you now to join this cosmic journey, subscribe, and be part of our exploration of the universe. Now, let's step closer to the sun's final act. We've already seen glimpses of the sun's fate. Billions of years from now, it will leave its stable middle age behind and swell into a red giant. But this swelling isn't a smooth or peaceful process. It's turbulent, violent, and unpredictable. Astrophysicists explain that as hydrogen in the sun's core is consumed, fusion slows down. The outward pressure that balances gravity begins to weaken. Gravity, always patient, pushes inward, compressing the core. This compression heats it further, sparking a new round of fusion, not of hydrogen in the core, but in shells surrounding it. This ignition causes the sun's outer layers to balloon outward. Imagine the sun, today 1.5 million kilometers across, swelling until its radius is nearly 200 times larger. Its outer edge could extend as far as Earth's orbit. For our planet, this is catastrophic. Earth may be consumed, or, if barely spared, scorched into a barren wasteland where oceans boil away and rocks glow with heat. NASA simulations show the sun glowing a deep red-orange, its atmosphere unstable and shifting. Powerful stellar winds, streams of charged particles blow outward, stripping planets of their atmospheres and carrying matter into space. This is not a quiet, fading sun. It is a giant, unstable furnace lashing out in its final rage. As the red giant expands, the solar system is thrown into chaos. Mercury and Venus will almost certainly be swallowed. Earth's fate, still debated among scientists, depends on small but crucial details. How much mass the sun loses in its stellar winds, how Earth's orbit shifts in response, and whether tidal forces pull it inward. Dr. Klaus-Peter Schroeder of the University of Guanajuato and Dr. Robert Conan-Smith from the University of Sussex have modeled this in detail. Their work suggests that Earth may be consumed. Even if not, it would be left completely uninhabitable long before the sun actually reaches it. Within just a few 100 million years of the red giant phase beginning, Earth's surface temperatures would rise to levels where no liquid water could exist. The biosphere, once rich and green, would collapse into silence. Further out, Mars might briefly warm, perhaps even allowing liquid water to return for a short cosmic instant. But this reprieve would be fleeting. As the sun continues its violent growth, Mars too will be stripped of its atmosphere, its surface blasted by radiation. Jupiter and Saturn, our great gas giants, will not be swallowed, but they will change. Their upper atmospheres will absorb the intense radiation of the swollen sun, possibly changing their colors and chemistry. Their icy moons, Europa, Ganymede, Titan, may temporarily melt, their surfaces awakening with oceans of water or methane. a fleeting paradise, quickly destroyed as the sun's fury grows. Eventually, the sun's instability reaches a breaking point. It cannot hold on to its outer layers any longer. With each pulse of fusion in its shell, the sun pushes matter outward. Wave after wave of its atmosphere is blown into space. This process creates one of the most beautiful sights in the cosmos, a planetary nebula. The term, first coined by 18th century astronomers, is misleading. It has nothing to do with planets. Instead, these are vast, glowing shells of gas expelled by dying stars like our sun. Through telescopes, they appear as ghostly halos, circular or elliptical shapes lit up by the fierce ultraviolet radiation from the dying core. NASA's Hubble Space Telescope has revealed breathtaking images of these nebula: the Ring Nebula, the Helix Nebula, the Cat's Eye Nebula. They are stunning, colorful structures lasting for tens of thousands of years. The sun, too, will leave such a legacy, a cosmic artwork painted across space, glowing with hues of red, blue, and green as different elements radiate light. In this moment, the sun will shed nearly half of its mass. The solar system will expand, planets drifting farther from what remains of their parent star. But the nebula is temporary. After some tens of thousands of years, a blink in cosmic time, it will fade, dissipating into interstellar space, enriching it with heavier elements forged in the sun's core. Every carbon atom in our bodies, every oxygen atom we breathe, owes its existence to stars that died before our sun was born. And one day, the sun itself will give back its own elements to the cosmos, perhaps to form new stars, new planets, and new life. When the last outer layers are gone, what remains is the sun's heart, a dense, Earth-sized core known as a white dwarf. This white dwarf will be astonishingly small compared to the red giant that preceded it. Imagine compressing something with the mass of the sun into an object no bigger than our planet. Its density defies imagination. A teaspoon of white dwarf matter would weigh several tons. The sun will no longer produce energy through fusion. Instead, it will glow faintly with residual heat, shining like a dying ember. For billions of years, this white dwarf will slowly cool and fade, radiating away its last energy. Scientists at NASA describe white dwarfs as stellar grave markers. They tell the history of stars long gone. Studying them in nearby star systems gives us a glimpse of our own sun's fate. Far, far in the future, after trillions of years, the white dwarf will cool so much that it will no longer emit visible light. It will become a black dwarf, a dark, cold remnant, invisible against the night sky. But here's the astonishing truth. The universe is not old enough for any black dwarfs to exist yet. The universe is 13.8 billion years old, while it would take quadrillions of years for a white dwarf to fully cool. That means no astronomer has ever seen a black dwarf. They are predictions, waiting in the darkness of a future universe. The sun will one day be one of them, a silent cinder, orbiting the galaxy with its cold planets, a star, long dead but still moving in the endless sea of the Milky Way. For us, the story of the sun's death is not just science, it is personal. Earth, our home, is directly tied to this fate. If we survive as a species long enough to witness the sun's transformation, we will need to leave Earth behind. The search for exoplanets, worlds around other stars, has become one of NASA's greatest missions. Telescopes like Kepler, TESS, and the James Webb Space Telescope are hunting for Earth-like worlds where life could continue. Perhaps one day, our descendants will call another planet or another star system home. This is why understanding the sun's death matters. It is not just curiosity about the future. It is about survival, about preparing for the long-term destiny of humanity. When the sun approaches the climax of its red giant phase, its outer layers begin to pulse outward in gigantic convulsions. Imagine a heartbeat, but on the scale of an entire star. Each pulse pushes material farther into space, shedding billions of tons of hydrogen and helium with every breath. These are not subtle events. They are violent expulsions of matter, painting streaks of glowing gas across the void. gas that will remain visible for thousands of years to any distant civilization fortunate enough to look in our direction. This stage is called the planetary nebula phase. Although the name is misleading, it has nothing to do with planets. The term was coined centuries ago when early astronomers, peering through primitive telescopes, mistook these glowing orbs for distant worlds. In reality, they are the beautiful death shrouds of stars like ours, clouds of stellar material expanding outward in brilliant colors. Greens, reds, and purples. Each hue corresponding to a different element released by the dying star. Oxygen glows green. Hydrogen burns red. Nitrogen radiates violet. Together, they form cosmic paintings that can span light years across. One day, our sun will craft such a painting. Astronomers predict it will glow like a jewel in the Milky Way, perhaps visible even from other corners of our galaxy. For a few tens of thousands of years, a blink of an eye in cosmic terms, the solar system will host a glowing nebula, a final performance before silence. But what about the planets in those moments? Earth, as we've said, may already have been incinerated, or at least rendered unrecognizable. Mercury and Venus will be gone entirely, swallowed. Mars may survive physically, but its surface will be stripped bare, baked, and transformed into a wasteland more desolate than it is now. The outer giants, Jupiter, Saturn, Uranus, and Neptune, might still orbit, but even their mighty atmospheres will not go untouched. The solar wind from the dying sun, now magnified to unimaginable strength, will peel away particles from their upper atmospheres, reshaping them. The beauty of the planetary nebula will be a paradox. To a distant civilization, perhaps observing through telescopes, it will look like one of the most stunning wonders of the galaxy. But up close, to any remnants of our solar system, it will be the aftermath of devastation, a reminder that beauty and destruction often walk hand in hand in the universe. At the center of this nebula, a transformation is taking place. The sun's core, having lost its outer layers, is exposed for the first time. No longer shielded by the dense blanket of plasma, the core shines directly into space, glowing white-hot. This is the birth of a white dwarf, a star unlike any other we've encountered so far in our journey. White dwarfs are remarkable objects. Though they contain about half the mass of the sun, they are squeezed into a sphere not much larger than Earth. Imagine compressing all that material, all those nuclear ashes, into something the size of our planet. The density is almost incomprehensible. A single teaspoon of white dwarf matter would weigh several tons. Its gravity is fierce, pulling inward with the strength of a collapsed giant, yet balanced by a strange force known as electron degeneracy pressure. Here's where physics takes us into almost surreal territory. In ordinary matter, atoms are spaced apart, their electrons moving freely. But inside a white dwarf, the collapse squeezes those atoms so tightly that the electrons are forced into their smallest possible states, packed shoulder to shoulder. This quantum effect prevents the star from collapsing further. Without it, gravity would crush the star into a neutron star or even a black hole. But for stars like our sun, the white dwarf stage is the natural conclusion. For billions of years after its death throes, the sun will sit as a glowing white dwarf at the center of the solar system. It will no longer produce energy through fusion. The fires will be out, but it will shine faintly with residual heat, cooling ever so slowly. To any surviving observer, the sun will appear as a dim ember, a ghost of its former self. The solar system will be a graveyard, lit only by the fading light of this remnant. Scientists estimate that a white dwarf can take trillions of years to cool completely. That's longer than the current age of the universe, which is just under 14 billion years. This means that no white dwarf in the cosmos has yet had time to fade entirely. Theoretical astrophysicists predict that eventually, over incomprehensible timescales, white dwarfs will cool into what are called black dwarfs, cold, dark remnants of stars, radiating no light at all. But the universe is still too young for any to exist. Our sun will one day join this silent population, but only in an unimaginably distant future. And what about the solar system's fate as the sun transitions to this ghostly state? Gravitational dynamics will change. As the sun loses mass during the red giant and planetary nebula stages, its grip on the planets will weaken, orbits will expand. Jupiter, Saturn, Uranus, and Neptune will drift farther out, released slightly from the sun's pull. The architecture of the solar system will stretch, like a rubber band loosening after tension. Some scientists even suggest that smaller objects, asteroids, comets, maybe even dwarf planets like Pluto, could be flung entirely free, drifting into interstellar space as lonely wanderers. The cosmic neighborhood we know today will be forever altered. No warm sun to guide the planets, no habitable Earth to sustain life, only a dim ember at the center, surrounded by drifting relics. And yet, there is a strange beauty in this inevitability, because while the sun's death marks an end for our solar system, it also marks a new beginning for the universe at large. The elements scattered during the planetary nebula stage, carbon, nitrogen, oxygen, will enrich the interstellar medium. One day, they may be drawn into clouds that collapse into new stars, new solar systems, perhaps even new life. The death of our star will contribute to the endless cycle of cosmic rebirth. This is the profound truth astrophysicists remind us of. Stars must die for life to exist. Every atom in your body heavier than hydrogen, every molecule of carbon in your cells, every atom of oxygen you breathe, was forged in the furnace of an ancient star. When our sun dies, it will give back to the cosmos, ensuring that the cycle continues. Now, let's consider the human perspective. For civilizations of the far future, if humanity or its descendants manage to survive until these distant ages, the sun's death will be a challenge of unimaginable scale. Already, scientists like those at NASA and ESA are speculating about ways civilizations might one day move to other stars, colonize other planetary systems, or even harness the energy of different stars to continue thriving. Projects like the Starshot Initiative or concepts like Dyson spheres are whispers of that future. Humanity may one day need to master such technologies, not as science fiction, but as necessity. The sun's death will not come as a surprise. We know it is inevitable. But foreknowledge brings opportunity. Perhaps by then, we or whoever inherits the mantle of intelligent life from us will have long since spread into the galaxy, building homes under younger, more vibrant stars. Perhaps the death of the sun will be a moment of remembrance, rather than an existential threat, a marker of where we began, not where we end. As we reflect on these immense cosmic timescales, let's pause for a moment. If you're captivated by the story of our star and its destiny, make sure you've subscribed to Starsky Science. Together, we're not just exploring the facts, but the meaning behind them, the threads that connect our lives to the vast machinery of the cosmos. The white dwarf stage is not the end of the story, though. To truly understand the sun's fate, we must also understand how it fits into the grander evolution of stars and galaxies. Because the end of one star is never isolated. It ripples outward, influencing star formation, galactic chemistry, and even the possibilities of future civilizations. So let us dive deeper still into the slow cooling of white dwarfs, the physics of black dwarfs, and the fate of the universe itself. Because to answer the question of the sun's death is also to ask, what happens to everything after the last star fades? The planetary nebula that marks the sun's death is not the end of the story, far from it. What remains at the center, after the glowing shell of expelled gas drifts away into the galaxy, is a small but incredibly dense object. This remnant is called a white dwarf. At first glance, the phrase might not sound particularly dramatic, but what hides within it is extraordinary. A white dwarf is essentially the exposed core of a star, compressed into an object roughly the size of Earth, yet carrying a mass comparable to the sun. Imagine compressing all the weight of the sun into something no larger than our planet. The density is so extreme that a single teaspoon of white dwarf matter would weigh several tons, perhaps the equivalent of an elephant compressed into a sugar cube. The sun, once a blazing giant dominating the sky, will shrink into this tiny glowing ember. Its once mighty nuclear furnaces will have been extinguished, leaving no fusion to generate energy. And yet, the white dwarf will continue to shine faintly, not because it is burning anything new, but because it retains immense residual heat. Like an iron bar removed from a forge, It glows brightly at first, then slowly cools over time. But time in this case doesn't mean millions of years. It means billions and trillions. When our sun finally settles into its white dwarf stage, it will be unimaginably dense. Scientists estimate that the sun's white dwarf will have a surface gravity 100 times stronger than Earth's. Standing on its surface, if that were even possible, would crush a human instantly. Light itself would be noticeably bent by this gravity, a phenomenon predicted by Einstein's theory of general relativity. Despite its immense density, a white dwarf is not completely inert. It holds within it fascinating physics. The matter inside is something we do not encounter in everyday life. It is called degenerate matter. In normal stars, like our sun today, pressure comes from the heat of fusion pushing outward against gravity. But in a white dwarf, fusion has stopped. So what prevents the star from collapsing further? The answer lies in quantum mechanics. Specifically, a principle known as the Pauli exclusion principle. This principle states that no two electrons can occupy the same state at the same time. In the extreme density of a white dwarf, electrons are squeezed so tightly together that they resist further compression. This resistance, known as electron degeneracy pressure, holds the star up against its own crushing gravity. It is a quantum effect on a cosmic scale, keeping the remnant of a star from imploding. Over billions of years, the white dwarf will gradually cool. At first, it will glow white hot, then fade to a dull red, then to an invisible black. Scientists call this final state a black dwarf, a star that no longer shines, cold and dead, a cinder of what was once brilliant. But here's the catch. The universe itself is not old enough for black dwarfs to exist yet. The oldest stars we know of have only been around for about 13.8 billion years, the age of the universe. White dwarfs take far longer to cool completely, perhaps hundreds of billions or even trillions of years, which means, as far as we can tell, no black dwarfs have yet formed anywhere in the cosmos. Our sun, one day, will be among them. But that day lies so far into the future that the very shape of the universe itself may be different by then. This is one of the mind-bending truths about astrophysics. When we talk about the death of stars, we deal with timescales far beyond human comprehension. The rise and fall of entire civilizations, the lifespan of species, even the history of Earth itself, all of it seems like the blink of an eye compared to the slow fading of a star into darkness. So, what happens to the rest of the solar system when the sun becomes a white dwarf? The answer is complex, and scientists are still piecing it together. But let's walk through the possibilities. The inner planets Mercury and Venus will almost certainly be gone by the time the sun reaches the white dwarf stage. They will either be engulfed by the sun's expansion during its red giant phase, or blasted apart by the intense solar winds that strip away the star's outer layers. Earth's fate is more uncertain. Some models suggest it will be swallowed as well, consumed by the expanding red giant. Others hint that it might narrowly escape engulfment, its orbit pushed outward as the sun loses mass. If Earth survives, however, survival will be only in name. The planet will be scorched and sterilized, its atmosphere stripped, its oceans boiled away. It will be nothing more than a charred, barren rock orbiting a tiny white dwarf sun. The outer planets, Jupiter, Saturn, Uranus, and Neptune will likely remain intact. Their great distances from the sun mean they won't be directly consumed, but their orbits will shift outward as the sun sheds nearly half its mass during the red giant phase. For instance, Jupiter's orbit may double in size. This shift will destabilize some of their moons and the icy objects in the Kuiper Belt, sending some tumbling into deep space and others crashing inward toward the white dwarf. It is even possible that new planetary systems might form from the material ejected during the sun's death. Astronomers have observed dust disks around white dwarfs, suggesting that remnants of planets and asteroids can coalesce into new structures. In a sense, even after its death, the sun could seed the formation of new cosmic objects. When the sun's planetary nebula drifts away, it will not vanish into nothing. Instead, it will enrich the galaxy. The carbon, oxygen, nitrogen, and other elements created inside the sun will be spread into space, to one day become part of new stars, planets, and even life. This recycling is one of the most profound truths in astronomy. Stars must die for new stars to be born. Every atom of carbon in your body, every breath of oxygen you take, every molecule of calcium in your bones, all of it was forged in the heart of a star. The sun, when it dies, will continue this cosmic cycle. Its ashes will become the seeds of future creation. We don't have to wait billions of years to see what our sun's fate looks like. Astronomers already observe white dwarfs scattered throughout the galaxy. One of the most famous is Sirius B, the companion to the brightest star in our sky, Sirius. While Sirius itself is a luminous main sequence star, Sirius B is its faint, dense partner, a white dwarf nearly invisible next to its brilliant sibling. Studying stars like Sirius B gives us a window into our own sun's destiny. It allows scientists to test theories about stellar evolution, cooling rates, and the strange physics of degenerate matter. Every white dwarf we observe is like a time machine, showing us what awaits the sun billions of years from now. For us, of course, these events lie far beyond the horizon of human history. By the time the sun becomes a white dwarf, Earth will long since have become uninhabitable. Humanity, if it survives, will have moved on to other planets, other star systems, perhaps even other galaxies. And yet, contemplating the sun's death has meaning even now. It reminds us of our fragility, of the fleeting nature of our existence in cosmic terms. But it also connects us to the stars in the most intimate way. When we look at the sun, we are looking at the very process that made us possible. And when we think of its eventual death, we are reminded that even endings in the universe are not truly final. They are transformations, transitions, steps in a cycle that spans billions of years. If you're finding yourself fascinated by the grand story of our sun and the mysteries of the cosmos, make sure to subscribe to Starsky Science. It's your way of joining us on this incredible exploration of the universe, where every star has a story worth telling. When the sun finally exhausts its nuclear fuel and collapses into a white dwarf, many might imagine that the story of our solar system ends there. But in truth, this is not the final chapter. It is merely the beginning of an extraordinarily long twilight that stretches far beyond the lifespan of any species, planet, or civilization that has ever walked the Earth. At the heart of this twilight is a glowing ember, no larger than Earth itself but unimaginably dense. A white dwarf, the remnant of our once glorious sun. For billions of years, this faint star will shine not through fusion, but through the gradual cooling of residual heat, like the glow of a dying coal in a fire pit that refuses to be extinguished. It will not burn brightly, but it will persist. And during this staggering expanse of time, the solar system will undergo transformations stranger and more dramatic than anything we have seen before. Here at Starsky Science, we explore these profound questions. What becomes of Earth, Mercury, and Venus after the sun dies? Will the planets remain bound to this faint stellar corpse, or will they drift into the cold silence of interstellar space? And what about humanity? Could a civilization that survives billions of years into the future ever escape such a fate, or even learn to manipulate dying stars to keep the fire of life burning longer? The sun, now a white dwarf, will be a pale shadow of its former self. Instead of a blazing yellow disk, it will glow with a cold white or bluish light, radiating from a sphere only slightly larger than Earth, yet packing in about half of its original mass. This means the sun's gravity will still hold some sway, but it will no longer have the same control over its planets as before. Mercury and Venus, having been swallowed during the sun's red giant phase, will no longer exist as distinct worlds. They will have melted, disintegrated, or been vaporized into clouds of plasma that were reabsorbed by the sun, or dispersed into interstellar dust. But Earth's fate is far more intriguing. For decades, astronomers debated whether Earth would also be consumed by the sun during its red giant stage. Some simulations suggest our planet might be engulfed, while others propose it will narrowly escape, its orbit stretched outward by the sun's mass loss. If Earth does survive, it will be a barren husk, its oceans boiled away long ago, its crust charred into molten stone, and its atmosphere completely stripped away. Around the white dwarf sun, Earth may circle in silence, a frozen relic, a reminder of what once was. Alternatively, gravitational interactions with the remaining planets or with passing stars could hurl Earth into interstellar space. Imagine that, our home world drifting alone, untethered across the dark void, carrying with it the ruins of a world that once teemed with life. The death of the Sun introduces a profound instability. When the Sun shed its outer layers to form a planetary nebula, it lost nearly half its mass. This sudden reduction in gravity means that the orbits of the remaining planets will expand, stretching farther into the solar system. Jupiter, Saturn, Uranus, and Neptune, the gas giants, will still exist, their massive bulk too large to be vaporized. But their orbits, too, will change. The solar system may become gravitationally chaotic over timescales of billions of years, with planets tugging on each other in slow, relentless dances. Astronomers predict that in the very distant future, this instability could result in planets being ejected into interstellar space, one by one. Over quadrillions of years, the solar system may unravel entirely, leaving only the lonely white dwarf drifting through the galaxy, perhaps without any companions at all. This long, slow dismantling of the solar system is not unique to us. Every star like our Sun faces the same fate. White dwarfs across the galaxy tell this story. Stars that once blazed with brilliance, now reduced to cold embers, orbited by the shattered remnants of their planetary families. Some white dwarfs even bear scars of cannibalized planets, rings of debris that formed when worlds were torn apart by their gravity. Could our Sun one day wear such a crown of broken planets, encircling it with silent ruins? The real question for us, as conscious beings capable of foresight, is this: if humanity or its descendants are still alive by then, what role could we play in this future? If we assume that technological civilizations advance without collapsing, then within just a few million years, an eye blink compared to stellar timescales, our species could spread far beyond Earth. Colonies could form around other stars, or even inside massive space habitats orbiting planets and asteroids. Humanity may not merely watch the Sun die, we may leave long before, carrying our culture, languages, and ideas to other corners of the galaxy. But some scientists and futurists speculate about something even bolder: the possibility of stellar engineering. Could an advanced civilization manipulate stars to extend their lifespans? Ideas range from feeding a star hydrogen harvested from gas giants, to reigniting white dwarfs with controlled fusion, or even constructing Dyson spheres to harness and redirect energy. These concepts may sound like science fiction, but remember, fusion power itself was once thought to be fantasy, and today it is a goal actively pursued by some of the brightest minds on Earth. If life truly wants to survive across the grand sweep of cosmic time, then perhaps stellar engineering will not be optional, it will be essential. Over trillions of years, the Sun's white dwarf form will continue to cool. Slowly, its glow will fade, from white to red, and finally to black. Astronomers call this theoretical end state a black dwarf, a stellar corpse so cold and dark that it emits no visible light. The universe is not old enough yet for any black dwarfs to exist. Even the oldest white dwarfs we've found are still glowing faintly. But given enough time, 10 to the power of 15 years or more, our Sun will eventually become one of these black dwarfs, a frozen ball of carbon and oxygen atoms locked in crystalline form. Imagine a diamond the size of Earth, drifting silently through space. That is the ultimate fate of our Sun. By then, the memory of life on Earth may be gone, or it may live on across distant stars and galaxies, carried by beings who look back at their ancestral home with awe. What's remarkable here is not just the fate of our Sun, but the sheer scale of time we're dealing with. Billions, trillions, quadrillions of years, numbers so vast they strain the limits of human imagination. To put it into perspective, the entire span of recorded human history from the earliest writing in Mesopotamia to the present day is barely 50 years. Even the age of Homo sapiens, our species, is only about 300 years. Compare that to the billions of years the Sun has already lived, and the trillions it will persist as a white dwarf, and we realize that we occupy just a flicker in the life of the cosmos. This perspective is both humbling and inspiring. It reminds us of our fragility, but also of our potential. For though our lives are short compared to stars, we are capable of understanding their fate. And with that understanding comes power, the power to prepare, to dream, and perhaps to endure. The story of our sun has carried us across billions of years through its birth. In a swirling nebula, its long middle age as the life-giver of Earth, and the dramatic finale that awaits it in the distant future. Now, as we reflect on everything we have uncovered, we begin to understand that the sun is not just an object in the sky. It is our cosmic parent, our clock, our energy source, and ultimately, the author of our destiny. And when it dies, it will not be the end of a single star, but the final chapter of a story that defines the solar system itself. Scientists often describe the sun's life as a cycle, one that mirrors the cycles of stars across the universe. What makes it remarkable, however, is that we are here right now to study it, to measure it, to imagine its future, and to prepare ourselves for the consequences. For every planet orbiting this star, every living creature depending on its warmth, the sun is both a protector and a destroyer. It gives life, and it will one day take it away. This reality forces us to look not only outward into the cosmos, but inward into what it means to exist under the rule of time. When astronomers peer into distant galaxies, they're not just looking at faraway stars, they're glimpsing countless other suns. Each one burns, evolves, and eventually dies. Our star is ordinary by cosmic standards, yet to us, it is extraordinary. Without it, Earth would never have formed as it did. Without it, life would never have blossomed here. And without it, human beings would not have emerged to ponder the universe at all. That is perhaps the greatest irony. The very sun that makes our existence possible will eventually destroy the environment that sustains us. But this is not a reason for despair. In fact, it is the essence of cosmic evolution. Stars are born, stars live, stars die. In their death, they give rise to new matter, new elements, and eventually, new stars. As Carl Sagan once said, we are made of star stuff. The calcium in our bones, the iron in our blood, the oxygen we breathe, all of these were forged in the hearts of stars, long dead. The sun, too, will contribute to this endless cycle when its time comes. And so, as we consider the sun's ultimate fate, we are also reminded of our own place in the great unfolding of the cosmos. Earth is a temporary haven, one that depends entirely on a star with a finite lifespan. Humanity's survival, therefore, may depend on its ability to look beyond Earth, to travel beyond the solar system, and perhaps even to seek out other suns that might serve as future homes. This is why the study of stars is not just scientific curiosity, it is a blueprint for survival. NASA scientists often emphasize that understanding the sun's death is a way of preparing for the distant future. Though its demise is billions of years away, the knowledge we gain today shapes our imagination of tomorrow. Missions like the Parker Solar Probe and the Solar and Heliospheric Observatory are not only revealing the sun's present-day secrets, but also giving us a glimpse into its long-term destiny. By studying solar winds, flares, and magnetic activity, we can project what will happen when its core runs out of fuel. This is more than an academic exercise. It is humanity's attempt to see farther ahead than ever before. As the sun swells into a red giant, as Mercury and Venus are consumed, and as Earth's oceans boil away, our planet's story will come to a close. But the legacy of life on Earth may not vanish. By then, humanity, or whatever intelligent descendants of humanity exist, might have carried seeds of Earth elsewhere. Imagine archives of our history stored aboard starships, DNA preserved and sent to distant planets, or even entire colonies thriving under the light of younger, more stable stars. The death of the sun may, in fact, mark the beginning of a new chapter for life. Yet there is also a poetic truth here. For all of our science, for all of our predictions, the sun's end is a reminder that nothing in the universe is permanent. Galaxies change, stars fade, planets are born and destroyed. Even the universe itself is evolving toward an uncertain destiny. In this light, The sun's death becomes more than a scientific forecast. It becomes a lesson in humility. We are small, we are fragile, and we are temporary. But in that smallness lies something extraordinary: awareness. The fact that human beings can sit on a tiny planet, orbiting an ordinary star, and imagine the star's death billions of years into the future is a profound miracle. No other species on Earth can contemplate such vast timescales. No other form of life can write its own future by imagining the end of its parent star. This ability to look forward, to plan, and to wonder, this is what makes our story inseparable from the sun's. Some scientists suggest that by the time the sun becomes a white dwarf, Earth may already be gone, either swallowed by the dying star or cast adrift into the cold void. But others point out that fragments of Earth may survive, orbiting the remnant sun in silence. Perhaps billions of years from now, some alien traveler passing through what was once the solar system will see the shattered remains of our world and wonder, did life once exist here? Did intelligence once flourish under this long-dead star? In that sense, even if humanity does not endure, the memory of Earth may still be written in the rocks, in the orbits, and in the faint glow of a white dwarf that was once our sun. As we stand at this point in history, with billions of years still ahead before the sun's death, we are left with a choice. We can live as though our time here is endless, or we can embrace the truth of impermanence and use it as motivation. The sun's death may be far away, but other challenges face us now. Climate change, the fragility of ecosystems, the need to sustain life on our planet in the present. In a sense, studying the sun's future is also a reminder of how precious the present truly is. We are living in the golden age of the sun, the stable era that makes civilization possible. Every sunrise, every beam of light that touches Earth is part of a cosmic clock, ticking forward toward an inevitable end. And yet, within that ticking clock lies opportunity, the chance to thrive, to explore, to create, and to prepare. The sun will not last forever, but the story it powers our story can continue long after it is gone. For the viewers of Starsky Science, this reflection is more than just astronomy. It is a call to wonder. It is an invitation to think of yourself as part of a story much larger than anything in daily life. When you look at the sun, you are seeing not just a star, but a timeline, a destiny, and a reminder of how interconnected everything truly is. The sun's death is inevitable, but so is the rise of new stars, new worlds, and perhaps new life that will look back at their parent stars and wonder the same things we wonder today. As we move toward the end of this cosmic reflection, let us take a moment to consider what the sun's eventual death truly means for us, not only as individuals, but as a species, as a civilization, and as a conscious life form that, for the first time in the history of Earth, can predict the destiny of its star. The sun will not explode violently like a supernova, tearing apart everything in a catastrophic blaze. Instead, its demise will be slow, majestic, and inevitable. Billions of years from now, it will expand into a red giant, shedding its outer layers, painting the cosmos with gas and dust, and eventually leaving behind a dense white dwarf, an ember of unimaginable density, glowing softly in the darkness. That image of our sun transformed into a ghost of itself should not fill us only with sadness or fear. It should also inspire wonder, because what the sun leaves behind, carbon, oxygen, and heavier elements forged in its nuclear heart, will seed the galaxy. One day, those materials may become part of new stars, new planets, and perhaps even new life. In this way, the sun will never truly die. It will continue to live on in another form, in another place, in another chapter of the universe's unfolding story. When we measure our lives against the cosmic timescale, our existence seems fragile, almost fleeting. A human life lasts decades, a civilization, perhaps a few thousand years, but stars live for billions. Our species has emerged in just the tiniest flicker of the sun's lifespan. We are latecomers to the stage, stepping into a drama that has already been burning for billions of years. Yet we are here at the perfect moment. The sun is stable. Its warmth allows Earth's climate to sustain liquid water, fertile soils, and vibrant ecosystems. It is a cosmic coincidence that our kind has arisen during this golden age, a time when the sun is steady and life has been given the chance to flourish. NASA scientists often remind us that we are living in the middle years of our sun's story. This is not a warning, but a gift. It means we have billions of years to learn, to explore, and to expand into the cosmos before the great changes begin. It means we are not running out of time tomorrow, but we must recognize that the clock is ticking, and no star, not even ours, can last forever. The sun's death is not an isolated story. All stars face their own destinies, depending on their mass. Massive stars die as supernovae, scattering heavy elements across space. Smaller stars, like our sun, fade into white dwarfs. Some stars merge, collapse, or explode, shaping the universe in ways we are only beginning to understand. By studying the sun, we learn about every other star. By understanding its cycles, its flares, its nuclear processes, we begin to unlock the rules of stellar life itself. That is why missions like NASA's Parker Solar Probe or ESA's Solar Orbiter are so crucial. Not only do they help us predict solar storms that could impact Earth, but they also deepen our grasp of the life cycle of stars. The sun is our nearest laboratory for astrophysics. It is a bridge between our fragile human lives and the grand, ancient laws that govern galaxies. And so, in studying the sun, we do not only study our star, we study the very language of the universe. There is a lesson hidden in the sun's eventual death, and it is a profoundly human one. Everything changes, and nothing lasts forever. Civilizations rise and fall. Mountains erode. Oceans shift. And even stars, those symbols of permanence in the night sky, are temporary. But impermanence does not mean futility. On the contrary, it gives meaning to existence. Knowing that the sun has a lifespan should not frighten us, it should remind us to cherish the light we have now. It should inspire us to use this era wisely, to nurture life, to explore, and to pass forward knowledge to future generations. Carl Sagan once said, "We are a way for the cosmos to know itself." If that is true, then our awareness of the sun's fate is itself a triumph of the universe. The atoms in our bodies were forged in stars, and now those atoms have assembled into beings who can look up, reflect, and understand. That awareness is our gift back to the cosmos. When we speak of the sun's death, it naturally raises a question. What happens to humanity? Could we survive the transformation of our star? Could we perhaps migrate to other planets or even other stars? Astronomers have long imagined the possibility. When the sun swells into a red giant, it will render Earth uninhabitable. But the outer solar system, moons of Jupiter or Saturn, or even distant dwarf planets, might briefly become warm enough for life. It is a strange thought that humanity might one day call Titan or Europa home, surviving on worlds that today are frozen and inhospitable. Of course, even that would be temporary. The sun's red giant phase will not last forever. Ultimately, survival would demand that our descendants learn to travel to new stars. It is a daunting challenge, one that requires technologies far beyond what we can currently imagine. But it is not impossible. The same human curiosity that once led us across oceans, that carried us to the moon, that now sends robots to Mars, this same drive may one day carry our descendants to other suns, under other skies. When the sun finally becomes a white dwarf, it will shine faintly for billions of years, slowly cooling until it is dark and cold. The Earth, if it still exists, will be a barren rock. The solar system will be a quiet graveyard of frozen worlds. But the sun's story will not be wasted. Its energy has already given rise to life, to consciousness, to civilizations that dream of stars. Its ashes will enrich the galaxy. Its light has painted Earth's skies with sunsets, nourished forests, powered oceans, and shaped every creature that has ever lived. The sun is not just a star, it is our star. It is the center of every myth, every calendar, every dawn. And even when it is gone, its influence will echo forever in the legacy of life it created. As we close this long exploration of the sun's life and death, take a moment to step outside and feel its warmth on your skin. That warmth is 8 minutes old. having traveled across 150 million kilometers of space to reach you. That warmth is the direct touch of a star, a fusion furnace, 4.6 billion years in the making. Every sunrise is a reminder of cosmic power. Every sunset is a promise that the light will return. And every heartbeat on this planet, every breath of air, every drop of water, all of it exists because of the sun. So, when the day finally comes, billions of years from now, when the sun breathes its last and leaves behind only silence, know this: it will not be the end. Its story will continue in the atoms of our bones, in the stars yet to be born, and perhaps in the footsteps of distant descendants who carry the memory of their home star into the galaxy. This is the story of our sun, our companion, our life giver, and it is also the story of us. Thank you for staying with Starsky Science through this incredible exploration. If you found wonder, inspiration, or a new perspective in these words, I invite you one final time to subscribe, so that together we can continue to explore the mysteries of the cosmos, one story at a time. Because as long as there are stars in the sky, there will be questions worth asking and journeys worth taking.